Welcome to my ECE 2001 Project 2 video. Spice design. So over here we have our aux and our mic inputs. They go into a summing amplifier and it goes to the LED or the laser right here. Over here, this is just the 8-level indicator that shows the indication of the level for it. Down here we have our laser input, or for the solar cell input, that goes into the 6 amplifiers. They amplify the signal for the speaker right here, and this has a low pass filter right here, or high pass, I'm not sure, one or the other. And this over here is our second 8-level LED indicator. This is going to be a brief overview because I went over this mostly in class, but basically we have input 1, input 2 that goes into our amplifiers. It gets summed together and then it gets outputted to the laser, and it just shows the level. This one again, we got the the signal coming from the solar cell getting cleaned by this filter right here, past this amplifier, and it goes into this other amplifier that amplifies the signal even more. And then it goes through another small filter, then goes to the speaker with this wire right here, taking it all the way to our another 8-level indicators. Right, so showing the simulation, I have it paused here because just to make it a bit easier. But basically we have our signal coming out of, let's say, this one here would be coming from our aux input, and this one right here will be coming from the mic input. And they both get amplified through this amplifier right here, as you can see, considering our old versus the amplified signal. Then it gets summed together to this one right here, summing amplifier, and then we get this signal coming out. That's right now peaking a bit, but that's because of the potentiometer up here. I did need to lower that a bit more. But yeah, basically this comes out and this goes down through our little safety resistor and then our laser. And then the rest of it goes to our 8-level indicator, which, as you can see, has a, well, depending on which point you pick, I'm going to go down here. Start from the bottom. Pick our positive. This one right here will be our, well, let me just clear it again. Right, as you can see, that versus right here, this is the point where like it all turns on and turns off. So if we compare the signals, you can see that, there we go, it will turn on when it passes this line, and it will turn off when it goes down past this line. It right now is going to saturate because this is probably the lowest one. This is probably when it turns on most of the time. Then as we go up, as you can see, the positive rail or the reference, that's our, yeah, negative is our reference. As you can see, our references change. And just a slight bit higher, meaning this one's going to turn on at slightly less intervals compared to this one. It's just slightly wider. I need to mess with potentiometers a bit more to get it to be just a bit wider. As you can see, it just goes out a bit more each time. And that's all because of the different, well, reference points set. And same with this L indicator down here. Starting again from the bottom, it's turning on and off where it stays mostly on. Taking a look here at the reference, and I would look at the positive signal coming from the solar cell. It's right now saturated again. I need to mess with potentiometers a bit more, but it shows the general gist that once it gets lower, it'll turn off. Once it gets higher, it'll turn on. And up here, it just looks a little bit better. See, it turns on just a little bit more. Well, a little bit less, it starts to blink more. And the higher we go up, the less time I'll spend on, the more time it's going to be blinking. And if we look compared to the reference, it's just slightly a bit lower. It all depends on the reference voltage. This right here is just the amplifier. If you take a look here, the signal coming out of this one, as you can see, we have a sinusoidal signal coming out from the solar cell and out of this input. And this signal is going towards the speaker right after capacitor, take out that little bit of noise. And that's kind of a description of this diagram. This is where me and Eric tested our two circuits at 30 feet. Show the bed.
It's my bag. This is coming from over there.
Show the solar cell.
Oh, yeah. Okay, so what? To the other side. That's my joint right there. These are coming. These are playing over here. So it's all like.
In this next clip, if you look at the oscilloscope that's in the background, you can see the readings coming from the solar cell that are being applied from Eric's laser. Okay, so we have testing. I'm here with Eric, and we have his board. So we have Taylor Swift playing there in the background. Connect to this board. His laser is right here, pointing it to my solar cell. We're getting this output. My board, and here's the speaker coming out of it. Here's my circuit being applied a sinusoidal signal coming from the function generator to the solar cell after the amplifier. That is what you'll be seeing on the oscilloscope. In the following video, you're going to see me testing my microphone input in on Eric's speaker.
You should go now.
Testing, 1, 2, 1, test. So I'm assuming it's so you can hear something coming from the speaker. Is that human voice? I have no idea. Here we have some measurements coming from my circuit. Alright, so the signal is coming to the speaker right now. We're taking a look here, coming from the capacitor, right between the filter, that goes to the speaker. I'm measuring it out right now. So we're getting a sinusoidal signal of about peak to peak about 0.7 volts, with an average of about 0.36 volts. Whereas compared to coming from the potentiometer, or that's coming to it from the laser, we're getting a sinusoidal signal. This is leaving the laser. You got peak to peak of 1.2 or 1.1 volts. And coming from the aux input, you have an input of about 3.6 volts peak to peak.